I'm going to be doing number 7 from chapter 8. It goes like this. Two objects are connected by a light string passing over a light frictionless pulley. As shown in figure 8.7, the object of mass 5 kilograms is released from rest. Using the isolated system model, determine the speed of the 3 kilogram object just as the 5 kilogram object hits the ground. Find the maximum height to which the 3 kilogram object rises. Alright, to start this off, we should just draw what's going on. So the initials on the left, what's happened, what we want to find pretty much the time point is on the right. And the 3 kilogram object is actually 4 meters high. To start, we can figure out, exactly what all the energy and where it's coming from. So you have U1, which is the potential energy of the first 3 kilogram object. You have U2, which is potential energy of gravity of the second object. And K, which is just any kinetic energy in the system, that's total energy. So setting those equal to each other for the initial over here, and then this part over here, U1 goes to 0 because it's on the floor. U2 we have, and K goes to 0 because right now nothing's moving yet. And then over here, U1 is going to be something. U2 goes to 0. And K we don't know what it is. So then we get U2 equals U1 plus K. Plugging everything we know, it's M2GH equals M1GH plus 1/2 mv squared. And the m, you actually add your two masses, because since the K is the kinetic energy in the total system, you use the total mass of the whole system. So it's 1/2 m1 plus m2v squared. Then continuing, you simply plug everything you know. M2 is 5 kilograms, gravity, height is 4 meters, M1, 3 kilograms, all that, 1/2. You solve for V and you get V equals 4.43 meters per second. Now next for B, it wants us to find the maximum height that this first object, the 3 kilogram one, goes. So we know that the 3 kilogram object is going to continue going up for some amount of time, because it has a velocity of 4.3 meters per second when the other object, the second one, hits the ground. And it's going to, fly up a little bit before falling back down. So we need to find that. So we know it leaves with the initial velocity from that 4 meter mark at 4.43 meters per second. We know we want the final velocity 0 meters per second, because that's at the peak of its, it's going up, it's going to slow down to 0, then it's going to start falling. And then we want the acceleration, negative 9.8 meters per second, so that's just gravity. So using one of our kinematics, Vf squared equals V squared plus 2x, 2a delta x. You plug everything in, and then you simply solve for delta x equals 1 meter. Well, that's the change in x from that 4 meter mark to how high it goes. So we need to add the 4 meters. Then we get an answer of 5 meters for B.